Schrodinger equation in spherical polar coordinates. You know, spherical polar coordinates are r, theta, phi. We are using time-independent Schrodinger equation and writing in 3 dimensions psi with respect to x, with respect to y, with respect to z. E minus v into psi equals. This is Schrodinger equation, time independent. You know what the relation between Cartesian coordinates x, y, z and spherical polar coordinates r, theta and phi. The relations are, you have to remember the relations. And how the relation comes, from where it comes. You please go to my video. I given the link in the description box for that how the relation comes. X equals to r sine theta cos phi, y equals to r sine theta sine phi, and z equals to r cos theta. Now scaling each term and adding, we'll get an equation x square plus y square z square equals to r square. Equation number 3. So it's a Cartesian system x, y, z. Polar systems r vector, theta and phi. Theta, this is z r. You know, consider the right angle triangle. Base upon hypotenuse is cos theta. From here, this line is perpendicular to XO y plane. This is a plane. So join origin to this point. Now this angle is phi, you know. The phi can vary from 0 to 2 pi. Draw a line parallel to y-axis. Because this is distance from the x-axis, we call it x. This line is parallel to y-axis. So this is y. Consider right angle triangle and y upon x, you know, y is perpendicular because this angle is 90. Y upon x becomes tan phi. So equation 5. Now equation 3 was, now differentiating partially with respect to x only. So 2r curly by curly x is equals to 2x. Curly by curly x becomes x upon r. Now equation 2 was x equals to r sine theta cos phi. Now substituting this x here. So curly r by curly x becomes r cancels out. Okay. So this is equation 6. Now equation 4 was cos theta z upon r, differentiating partially with respect to x. So you know it becomes, the differentiation of cos theta is minus sine theta because differentiation is with respect to x. So curly theta by curly x equals to minus z upon r square curly r by curly x. Now this value curly r by curly x, which was sine theta cos phi, substituting it here. Okay, sine theta cancels out, minus sine as well. So curly theta by curly x equals to z cos phi upon r square. This is our equation. From equation 2, z was equals to r cos theta. Just go back. Z was r cos theta. Substituting here, curly theta by curly x becomes r cancels out. This is curly theta by curly x. Equation number 7. Now equation 5 was tan phi equals to y upon x. Differentiating with respect to x. Secant square phi curly phi by curly x minus y upon x square. So this is the value of curly phi by curly x. From equation 2, y equals to r sin theta sin phi, substituting here, curly phi by curly x finally becomes. So, and from equation 2, okay, x was also equals to r sin theta cos phi. Just look back, go to back, and substituting x here. So, curly phi by curly x, some factor cancels out, minus sin phi upon r sin theta. This is equation 8. So equation 6, 7 and 8 already derived. Writing again. Okay. Now we can write curly psi by curly x as here the variation of psi with respect to x. Okay, curly psi by curly r by variation of psi with respect to r, psi with respect to theta, psi with respect to phi. But, like this factor, and this factor. So it is the same, curly psi by curly x. So substituting from 6, 7 and 8, these values. So curly psi by curly x becomes this is a curly psi by curly x minus sign here. Similarly, you find yourself curly psi by curly y and as well now one thing is clear. How to remember in the exam? Instead of cos phi, here sin phi. Instead of cos phi, here is again sin phi. Here sin phi, but the cos phi. Minus sign is now, here is the plus sign. You remember like this for writing in an exam. Otherwise, you can drive yourself. So, now again writing curly psi by curly, yes, similarly, it is having only two terms. So we are having, so this is equation 9, 10 and 11. So equation 9 was equation 10 and equation 11. Again writing psi, variation with respect to r, theta and phi. Now again differentiating it with respect to x. So just interchanging, like look the arrow. Okay, then the equation becomes now you already derived equation 6. Curly r by curly x is this value. Curly theta by curly x. Curly phi by curly x. The equation was 6, 7 and 8. Substituting the values. Okay. Substitution of the values. Now coming similarly 13 and 14. Now equation 12 was, now you look back equation 9. So what we will do now, I think it is understood. We'll substitute curly psi by curly x here, at here, at here. And operator is curly by curly r here. Here operator is curly by curly theta. It will operate on this equation. Here operator is curly by curly phi. It will operate upon this equation. So ultimately we are having now, when we substitute curly psi by curly x here, it comes out the 3 terms, 1, 2 and 3 with this operator. 3 terms here with this operator. Okay, and 3 terms here with this operator. So total terms becomes 9. There will be total 9 terms. Okay, now I'm going to substitute curly psi by curly x. Three terms plus again 3 terms plus again the 3 terms. So total terms becomes 9. Okay, now just see how the operator operates on the terms, and some factor comes outside the operator which are constant, because here the operator is r, so only r term remains inside, belonging to curly psi by curly x. So again, all the three terms, operator was curly by curly r, and only r terms remained inside, which was belonging to curly psi by curly x. Now here the operator is theta. So theta terms belonging to curly psi by curly x will be inside, and rest you can take out to the operator. So lastly, we are having the operator with respect to phi. So phi terms will be operated now. So total terms are 9. So this value is curly to psi by curly. This is equation 15. The 9 terms equation is 15. Now similarly, you find the value of curly to psi by curly y square and curly to y by curly z square. I am writing the result for curly to psi by curly y square. Okay. Again the operators are same. First three terms r operator, theta operator, then phi operator. Now adding equation 15 and 16, curly to psi by curly x square plus curly to psi by curly y square. Just adding a little simplification using trigonometry. And I think you are expert in elementary trigonometry. If you find difficulty, write me in the comment box if anything is not clear. So this is the result of curly to psi by curly x square plus curly to psi by curly y square. So the result on the right hand side is only with respect to r, theta and phi. Now equation 11 was, and 14 was, substituting here curly psi by curly z. So curly to psi by curly z square becomes okay. Now operator, here operator is with respect to r, here is operator is with respect to theta. Just solving, so we are having the 4 terms. Okay. So this is our equation of 18. Now adding 17 and 18, we'll get curly to psi, curly x square with respect to y square, curly to psi by curly z square equals to, because it is required in the Schrodinger equation. And we converted it in r, theta and phi. The right hand side is only containing the terms r, theta and phi. So this is the Schrodinger equation. Substituting here. Now Schrodinger equation is converted into spherical polar coordinates, mean in r, theta and phi. and little bit more simplification if you can do. Just see, nothing difficult. Okay. This can be put in the form. Because when you open this, when you do the partial differentiation with respect to theta to this term, and just do the simplification, you will get the same above equation. Very simple. But finally, this is our result. Okay? Thank you.